When we want to find life in the universe, there's a certain spot to look for. The Goldilocks zone. Goldilocks zone is the spot where the planet is at the perfect spot from their star, and you could find liquid water. So the planet can't be too close where it's raining fire, or too far when it's completely frozen. So to find life, we have to focus on planets that have liquid water. Science has taught us that if water is steamed or completely frozen, life cannot be found there. So planets in the Goldilocks zone have a high chance of having life. Why is the Goldilocks zone so important? Because this spot is where Earth is at. It's not too far from the sun, and it's not too close to the sun. So the farther we get from the sun, it gets colder and colder and more frozen, right? Last week, we made a video about Jupiter, and we saw how far it is from the sun. It's way too far from the Goldilocks zone, but one of Jupiter's moons, named Europa, even though it's really far from the Goldilocks zone, but it's kept warm. But Jupiter and its moons are really far from the sun. How is Europa being kept warm? This warmth is not coming from the sun, it's coming from the gravity of Jupiter. The same tidal force that happens on Earth, where the oceans move up and down, the same thing happens on Europa but at a bigger scale. And this giant planet keeps vibrating this planet. You could basically say Jupiter is pumping energy into this moon. Meaning, when Europa is spinning around Jupiter, Jupiter's gravity keeps making it an oval and then a circle, and then an oval and a circle, over and over. But not too fast where you can see it, but it is happening, and this movement causes heat. When Moon's gravity makes the tides go up and down on Earth, it's moving the water, but Jupiter is moving the hard surface in and out. And this causes more heat, and even though it's really far from the sun, it's kept warm. Europa is basically like a racquetball. It's interesting because racquetball players, before they warm up, they say let's warm up the ball. They literally want to warm up the ball. But how? Do they put it on the stove? No, they keep smacking it around. And every time they hit it, it turns into an oval and back to the circle again. And this motion causes heat. But how does this energy go into the ball? The energy that the racket puts into it. The racket and the strength of your arm is basically like Jupiter, and the ball is Europa. When you look at Europa, it's covered in ice, but when you look closely, you see all the ice have cracks in them, and unlike other icy moons, it's not a solid piece of ice. It's obvious that these ice moved around, broke, and refroze again. And these cracks shows us that this moon is not completely covered in ice. Well, if this moon was completely ice, you wouldn't see any cracks. If you fly over the Arctic Ocean in the winter and you look under, you will basically see what Europa looks like. Ice that have cracks and moved around and refroze again. Most astronomers believe that under the ice on Europa, there's water, liquid water. Basically, where there's liquid water, there should be life. But why do they call this sea the Dead Sea? Because when they named this sea, the microscope had not been invented yet, and they didn't know in this dead sea there's a lot of life. Yeah, obviously in the Dead Sea you can't find any fish, but there are a lot of bacteria that have been living there for millions of years with no problem. So we found a spot that there's a high chance there's liquid water, and there's a chance we could find life on there. And this has gotten scientists really excited to find life other than Earth, and we don't only have to look in the Goldilocks zone anymore. There are a lot of spots in the universe where it's not in the Goldilocks zone, and the host star is extremely far, but there's warmth and energy. NASA would like to go on Europa and study the moon, but it's not an easy task and it can't be done right now. First of all, it's really far, and any probe you send there is gonna take years to get there. And second of all, you have to know that this ice is not thin. It's not like it's a couple meters thick. This ice could be kilometers deep, and then under that ice there's liquid water. So it's a huge project and it can't be done easy. Jupiter has 79 moons, and you might be wondering, how come all of Jupiter's moons aren't warm? Jupiter keeps those guys warm too, but one of them a little too warm. Io, which is the closest moon to Jupiter, is kept extremely hot. This moon is so hot that the volcanoes can't turn off, and all this heat is caused because of Jupiter. And basically like the racquetball we were talking about is happening to Io, but at a higher scale. There are over 400 active volcanoes on this small moon, and this place is the most volcanically active place in the solar system. On Io, there can be life, but on Europa, there is a high chance we could find life. Europa helped scientists out a lot because it showed them that energy doesn't only come from a host star, but planets like Jupiter can produce a lot of energy. With today's technology, going to Europa and cutting the ice open and going in there is kind of impossible. But technology grows a lot day by day, and maybe in our lifetime they could go to Europa and for the first time they could find life other than Earth. You think this is possible in our lifetime? Please leave a comment.